I would like to welcome Newsha Ajami to the podcast. Newsha is the Chief Development Officer for Research in Earth and Environmental Area at Lawrence Berkeley National Lab in California. And prior to this position, Newsha served as the Director of Urban Water Policy for Water in the West at Stanford University. She is also the mayoral appointee to the San Francisco Public Utilities Commission. And she's currently serving on the National Academy of Water Sciences and Technology Board. Thank you so much, Newsha, for joining me today.
Thank you so much for the invitation. Really excited to be here.
And we connected recently at a National Academy meeting in California, which was a lot of fun. So Newsha's research focuses a lot on urban water policy and sustainable water resources management. And today, I hope we're going to talk about that topic within the context of climate extremes, droughts and floods, which you experience plenty of in California. And Newsha has an engineering background, but it combines it with social and economic aspects of water resources management. So I think that is really unique. And then we'll expand then to a broader topic of water, energy, and food nexus. And her research, she's done work in many different regions, but particularly in California and also in Colorado and Mexico. So I guess, Newsha, maybe we can start with urban water use, which you have been diving deep into for many years. Most of us live in urban areas and cities, and more people are moving to cities all the time. And your work and others suggesting that although the population is growing in many of these cities, that the water use is remaining stable. So suggesting that per capita water use has maybe stabilized to some extent. Can you describe this decoupling of the population growth and water use?
Yeah, absolutely. I think one thing that you just mentioned, the coupling between population and water use, actually, I think it's not just stabilizing, it's also declining. That's per capita water use. And a lot of that has happened for various reasons. One is the change in policies and codes, building codes and the way we use water in our homes. Some of it has been happening due to much more efficient appliances, more innovation around water, when it comes to how we use water at our homes and what appliances we use. And one very important thing in that process is also the fact that much of that saving happened during the energy transition, because as we all know, or if you don't know now, we know, is that we use a lot of energy to move water, to heat water, to treat water after it's used, the wastewater. So the less water we use, the less energy we use. So some of these transitions actually happened because we were trying to become more energy efficient. And some of the incentives that has been provided to people to replace their appliances and fixtures in their homes were actually partly provided by energy utilities to manage the water use. So it is also very interesting to kind of think about how one sector's policy shifts impacted another sector's, actions and use and demands. So I think that's an important thing for everyone to keep in mind. Another piece of it also has been, knowledge and awareness that has come around water, and I'm happy to talk about that a little bit more.
Right. So basically, the appliances that you're talking about, washing machines, low pressure showers, toilets, and all of these things, I mean, water use for all of these appliances has markedly declined in the past.
Absolutely. Absolutely. I mean, you have high efficiency now. It's like HE on everything, right? High efficiency washing machine, dishwashers. And these are all originally designed to reduce energy use. Now your dishwasher uses about 2 to 3 gallons, or in some cases up to 6 gallons to wash a load of dishes. I mean, that's so small compared to the old versions that are using a lot more water. But all that water needs to be heated up, right? sort of dried up at the end. So the less water you use, they need to use less energy for
Right.
that.
And that brings to mind, Newsha, I grew up in Ireland, and so we didn't have hot water all the time. We turned on these immersion heaters to heat the water. And if you left the immersion on, it was a criminal offense.
Yes,
And here we have hot water heaters that I don't
all the time.
Yes, right.
Yes, yes. I mean,
So,
there were also some unintended consequences as part of that. This is a great example. We used, when I worked for the legislature in California, we moved from San Francisco to Davis for a year, and we rented a place. And they had this instant heaters, which was supposed to be like very energy efficient because the water goes through this instant heater and warmed up, and then you can shower. The problem with the instant heater was I would be standing there waiting for 5 minutes for the water to warm up. So as a water enthusiast, that was a crime for me. I was like, oh my God, how much water do we use to prevent energy use, right? So it is kind of interesting to see how single-minded solutions sometimes can have not very good outcomes for other sectors or for the other resources.
right, right. And in your work and other people's also emphasize how much water is used for outdoor watering,
Yes.
irrigating gardens and stuff. And everybody wants to pretend like they live in the UK or something like that. Green lawns. And, some of your papers focused on drought periods in California, 2007 to 9 or 2012 to 2016. So that gave you a good opportunity to see how behaviors changed and what worked and what didn't work. How would you describe, how outdoor watering changed over those times? And I know you did a number of different studies looking at various aspects of that, but how would you describe those changes?
I think it will be interesting for your listeners to know that the biggest crop we grow in the US is grass. Not grass for feeding cows or that. It's basically grass that's only, for beautification, and it's non-functional grass, which actually I find it very distressing, to be honest with you, because a lot of that is not ever used or nobody steps on it or uses for various purposes. So that's actually one thing that's important to keep in mind. In California, we use more than 50% of our water to maintain outdoor spaces. And some of that is for, commercial buildings, big outdoor spaces or malls or these areas that, again, it's just there for being there, not because you want your kids to play soccer on or you want people to picnic on. So those are really big problems. And then I think there are a couple of aspects that goes into it. One is, as you mentioned, they don't belong to this area of the world. They're not meant to be for this. I mean, they grow places that you don't need to water them all the time. Then at the same time, we are treating water to the highest quality. We push it through people's pipes and distribution systems and ends up being used to watering grass that we have no purpose for it. So it's not just a water problem, it's also an energy and resource problem as a whole. So the question is, how do we really need this? Is there a way we can minimize this water use and make it become more efficient? You mentioned something at the beginning, which I actually did not fully go deep into, which was the whole decoupling between population growth and demand growth. And one big part of that, in addition to efficiency that we have been experiencing, is also because we have been reducing outdoor water use, trying to minimize outdoor spaces, trying to transition to native plants that use less water. So all of that also have been very instrumental to reducing per capita water use. For example, this is a very important example. Often, I'm sure you have heard this before, but for example, city of Los Angeles over the past, 40, 50 years have been using the same amount of water, even though their population has doubled. Very similar to the Bay Area. People have been using the same amount of water, even though our population has doubled. And much of that, in addition to efficiency and change in water use indoors, has also had to do with reduction in outdoor water use or minimizing that. So that is very important to keep in mind. And these are structural changes, right? People ripping off their lawn and replacing them. So we did a multitude of studies during the drought in California because it was an interesting experiment. I've worked with economists and social scientists, and it is super important in those fields to be able to kind of create this natural experiments that you can compare baseline to when you implement interventions. And some of these drought periods or some of the conditions that were already set in the cities that we worked with already were sort of offering us this natural sort of separation or natural clustering. What we had seen during the drought, one thing that was very interesting was the media coverage of the drought had so much to do with the water use reduction in California, more than all the resources that were put into, more than the restrictions, more than the incentives that were provided to people to replace their appliances. Like basically, if you might recall, during the 2012-2015 drought in California, like almost every newspaper outlet was writing about California's drought. The reservoirs are empty. The rivers are running dry. Different ecosystems are collapsing. Groundwater is declining. All that. It was almost every day. There wasn't a day that we did not have multiple articles about drought in California. And that actually led into people paying attention, trying to respond to it, trying to use less water, and ultimately changing their behavior significantly. And that was such an important and interesting sort of finding for us to see that, yes, it's important to continuously have different policies put in place, but increasing public awareness can really shift the way people use resources. And I don't think no one had really systematically done that study. We managed to kind of scrape the web for all the news outlets, the news articles that have been written on this, did a lot of modeling to better understand what was the impact. For example, you often hear people say income very much matters, price of water matters. That was a time of high employment. Actually, unemployment was declining, and the rate of unemployment was very low. We looked at the price of water. Price of water wasn't necessarily changing during some of that period. It took a few years before agencies started adding drought surcharges, and still people were their water use was declining. So, which was kind of showing that public awareness was important.
Well, I mean, it's nice to think that our media outlets and that we're not just oversaturated, and that some messages can still penetrate and
Yes.
have an impact. So that's a good thing. And I think some of your studies, you looked at whether they were using recycled water or fresh water. And then you also looked at the rebound effects, how many of the residential areas or commercial areas maintained those reduced water usage after the drought. And so which were structural, I guess, or which were temporary. I think those are very important aspects also, because we need to understand that when we're planning water availability and stuff.
Absolutely. I think those two studies, one was very interesting, the one on recycled water, again, another natural experiment. In one of the cities we looked at very closely, they had smart meters. So we could sort of see their daily water use very closely or track it. They had a number of people who had access to recycled water for their outdoor spaces. And during that period, there was no requirement for people who were using recycled water to use their water use, to change their water use. But there was very specific restrictions on people who were using potable water for their outdoor spaces. So actually, the utility was providing these messages to people that, don't worry if you're using, they would send messages to people with recycled water. Don't worry about it. You can use it. You are not subject to this restriction. But what we saw was still people reduced their water use, even if they had access to recycled water. Part of it was driven by the fact that they're like, what's the difference? I'm not, I think I should save the water, right? Another part of it was social norm that was, being picked up. Like everybody's glass was brown. How can I go and continue having lush green grass? So that was interesting. And so we saw, and some of it also was, these commercial buildings with huge outdoor spaces with green grass. And they did not want people, they didn't want to end up in the media saying, look, all the people, normal people are reducing their water use. And look at this so-and-so company with all these green grass outside. So it was a lot of public pressure to change water use, and people were reacting to it. So they didn't care about the social water, which is interesting and important, obviously, very, very important. Another piece that you mentioned, which is also another, it was interesting, is, we looked at the people's water use and tried to see who bounces back, because often utilities assume that these changes are temporary and people will rebound very quickly and go back to where they were before. But what we saw was almost like 30-40% of the people never rebounded, or actually whatever they did, they kept it where it was for at least 8 years. Their water use either was continually declining, or if it declined, stayed as such. Mm-hmm. And, that's very important, because the way we plan for our infrastructure is based on demand. And demand is based on how much water people use and how they change their behavior and sort of projecting the future demand. If demand is disconnected or decoupled from population, what else matters in projecting demand, right? And I think that's what we spent almost a decade trying to kind of understand beyond population and socioeconomic and climate, what are the other factors that goes into demand, basically impacts water use, and trying to see if we can introduce those into demand forecasting process, from public awareness to type of water people have, to the home, age of the home, the size of the home, and outdoor spaces and what kind of outdoor spaces people have. And also sometimes actually social beliefs. We also did look at political backgrounds, like we tried to kind of overlay political lineages in different regions and see if we saw more people in the, more liberal areas responding more to drought conditions versus the, more, right leaning people. So there's so many different things that goes into this, right? And we try to kind of test all these different hypotheses to see which one is important, which one isn't, which one has a huge impact, which one doesn't.
Right. I mean, it's very difficult to understand human behavior, and I think that's why the book Thinking Fast and Slow is extremely very interesting.
Very much, yes.
Because a lot of things are counterintuitive, and even when we know them, we still fall into the same, traps, whatever. But, you started off early on talking about saying that water and energy were highly connected and, all this outdoor water use. And I felt during the pandemic when I was working at home sometimes, it was like a war zone with all the competing lawnmowers and all this stuff, So it's just a huge industry for something that's really,
Huge industry.
yeah,
Yes.
yeah. And energy also uses a lot of energy in those blowers and noise pollution and, all of these things. So it's questionable whether we should continue in that mode. But
Actually, on that note, one quick thing I would say is one thing we found was in some of the high income areas, if people are not necessarily paying, they have either they're paying their bills automatically, or either because they have gardeners that come in and take care of their outdoor spaces and they're not having a lot of interaction with it. It just changes their water footprints very much, right? They're just sort of like, they do want to change, but they're not sure how. They don't know who is the right person to do it. And, and I think that very much has a big play into this.
Right. Yeah. So, that gets into the topic of utilities. And most utilities in the US that provide water, they're publicly owned. And, sometimes people find it difficult to understand, during the drought, they might ask people to conserve water, but then they might end up having a higher water bill. And, also during the pandemic, I think some of these types of things happen. So it's difficult for people to understand, some of these things, but understanding that utilities need to have their operational expenses covered and how they communicate to consumers. So this traditional centralized approach to providing water, and I know you work a lot with decentralized, so I would love if you could chat a bit about those centralized and decentralized and some of those issues.
Sure, absolutely. So let's just talk about utilities first, which I think is they provide such an important service to us, right? They operate and maintain our infrastructure. They make sure the water is delivered on time. I know there are some cases that we all hear and read in the newspaper about failing utilities, but 90% of the country receives water, high quality water out of their tap, on time with no disruptions. And that's a very important number. Now, the challenge of utilities is they were set during the 20th century. So they have their model was create abundance, be reliable, and have water delivered, right? And sort of don't ask a lot of questions, and make sure to send the bill to people, people pay their bill, done. There was no real relationship between the utilities and customers. And because water was often very cheap, still is one of the cheapest utilities that we have, no one really asks a lot of questions. And that actually has been a big issue because people, water infrastructure mostly is hidden, like underground pipes and all that. People don't know where the water comes from, where it goes, right? So they have no connection with that. And that's a huge issue because they don't know what they're paying for. When you ask people, are you paying for your water? They're like, yeah, we paid for our water. But the reality is nobody's paying for water. Often people are paying for their services that they're receiving from the utility. And as the infrastructure ages, as it becomes more complex, as the cost of energy goes up, this system needs more and more resources to be maintained and operated and all that. So it's, that is super important. Another piece of this utility business is often people were charged over time based on their volumetric water use. So you use whatever amount of water you use, there's a cost associated with every gallon that you use or every, depending on what, unit you're using. CCF is one of them. Then, based on those units, you use water and you're charged. The challenge is the fixed cost of operating and maintaining the system is very high. Basically, it ranges between 60% fixed cost, 40% variable cost, to up to sometimes in some cases, 80% fixed cost, 20% variable cost. So as people start using less and less water, that does not change the fixed cost that these utilities have. They still need to operate. Like, doesn't matter how many gallons of water you receive, I still need to operate the dam, take care of it, make sure it's in a good shape, make sure the pipes are in a good shape, make sure people are paid and are there to take care of the system. There's so much it takes so much to be able to deliver. Now, when people start using less water, that means that there's less revenue coming in. So the utilities have harder time to maintaining their financial health. In some cases, because they never had a very good relation, I don't want to say they have a good relationship. They never had a relationship with their customers beyond providing them a bill. Sometimes it's very hard for them to go ask for more money, because when you ask for more money, you have to justify why, right? And if you never build this relationship, how can you ask why? There's a baseline that needs to be set. So, and you didn't used to have these long droughts. I think that's what now, with climate change and these intense droughts that we are experiencing, it's becoming more and more obvious to people that, oh, we are having all these longer droughts. Now it's kind of like, oh, this is not a 3-year thing that goes away. Now we have like 5-year droughts, 6-year droughts, like longer, more intense. We lose resources much faster. So then when people use less water, utilities end up raising their rates or putting drought surcharge on their bill, which means they're charging them more, right? So people are like, oh, I use less water. Why are people, they asked me to use less water. Why are they charging me more? And that charging more is because they have to keep their financial health. And this is a conundrum, because this is basically highlights the fact that we have infrastructure and business model that was set in a different time for different conditions, for a different reality, right? Mm-hmm. And we live in totally different world with different realities and different needs and demands and challenges. And that institutional setup, business model, and infrastructure model does not lend itself to the situation we are in right now. And we are constantly dealing with that. So I think that's super important for people to know. It's kind of like, how do you modernize these utilities and water agencies to be financially sustainable, but still be able to provide this essential service that they're providing to people?
Right.
So I think that's very important.
Mm-hmm, mm-hmm. And so one thing that you do quite a bit of work on then is decentralization. I mean, people talk a lot about economies of scale and these sorts of things, but so a water treatment plant providing a reliable water source. I mean, the water treatment itself, I mean, those reverse osmosis systems for like a desal plant, they're modular, and there may be some advantages from economy of scale, but then that might be offset by the distance you might have to transport the water. So there are trade-offs between centralized systems and decentralized systems. And when I was listening to your podcast on the Stream podcast, you mentioned San Francisco, the land prices for a centralized system, and then requiring businesses to have their own wastewater reuse program. So maybe you could describe those a little bit, Newsha.
Absolutely. I think you touched on something super important, which is the utility business is also because of the way it was set up, as I mentioned, it was set up in a centralized way. So that's the only thing they know, because they like to, again, build big infrastructure that can continuously make them reliable, but still actually that continues to perpetuate the same problem they have right now. Somebody has to pay for that. People don't know where the water comes from. In many cases, when you're talking about centralized recycling and desal, we're talking about a lot of energy that needs to be used to treat and then move water back upstream for people to use, or new distribution systems need to be built to transfer that water. And again, I don't think we touched on this, but I think goes back to the distributed system, is that the same water that we have spent a lot of energy to treat and deliver, even more than what our conventional water sources, will be used to flush our toilets and used outdoors. Going back to what I said about the past century, at that time, we didn't have smart systems. We didn't know how to, we knew what we knew at a time. Now we have smart systems, we can track water quality, we can have systems that can, shut down something, operate another thing. We live in a totally different world. Your phones generate data like as we walk and talk, right? So we live in an digital era. Our water utilities are still in the, analog era. So if there is a way for us to not use drinkable water for flushing toilets, or not use drinkable water to water our outdoors, all of a sudden, we can reduce our indoor water use or even outdoor water use significantly, right? For example, let's just talk about it in a logical way. Our showers are next to our toilets, right? We use 30% of our indoor water use for showering, another 30% for toilet flushing. Just magically, these two numbers often match, right? A little bit up and down, but they do, right? So if you can put a decentralized system in place that takes the shower water, treats it, and directs it to your toilet, then all of a sudden you have a system that operates and functions very differently. All of a sudden your indoor water use reduces by 30%. Your demand reduces by 30%. Your baseline reduces significantly, right? So we do have these technologies now. It's sort of similar to people's, like, just to put it in context, solar panel that people put on their roofs, right? There are multiple values to this. One is all of a sudden people become much closer to the infrastructure that they need to live on a daily basis. You reduce the need for moving water through a complex system to come to your room, come to your house, and then flush it down, and then treat it again. And also, you kind of give people, and also you reduce demand, which means then you need less infrastructure, right? Less dams, maybe not. We don't need a huge infrastructure to maintain and operate this or meet the future demand. So that's super important. Now, this is easier said than done. I think that some of that is related to policy and changing policy. I think San Francisco was a leader in this process. In 2012, we passed an ordinance, actually, and I'll tell you why, but we passed an ordinance that says every new building that's larger than 200,000 square foot needs to have an on-site reuse system. So it means that you'll take the water from showers, sinks, like almost clean water, foundation water, rainwater, all of that. You treat it, and then you repurpose that water to flush toilets and maintain outdoor spaces. Mm-hmm. So there was, it was sort of like when you think about a utility business, you're like, which utility does that? That's like, that, hurts your baseline or bottom line in many ways. But it was a very logical reason for it. And the logical reason was, downtown San Francisco is very dense. We don't have tons of land in San Francisco. We are 7 mile by 7 mile. And building a recycling plant in downtown San Francisco that would have made sense would be very costly. But we also have a lot of development in downtown San Francisco, and there was a technological availability that could accommodate this policy. So they did it. They put a policy in place. And now at this point, we have almost like a lot of buildings in downtown San Francisco that they do that. We now reduce that square footage to 100,000 square foot or higher. Hopefully we'll reduce it even more. At this point, there are units that you can actually buy and put it in your shower in a retrofit process. This was for new buildings, right? But you can even retrofit your bathroom, and they put these units that basically takes your shower water and flush your toilet. So these systems are now out there. I think, I know that City of Austin now has the same policy. They implemented it, I want to say a couple months ago. Now they have an ordinance that requires the same thing. So it's kind of like picking up. So I find it very exciting because it kind of revolutionizes the way we do water, right? It changes the business model. Now, as we talked, we started from demand and we are back at demand again. This kind of thing reduces demand again significantly, right? By 30%, 40%, 50%, right? And that means that, again, for utilities, they have to account for this change. If they are not accounting for this change, that means they don't understand how much water they need to meet future demand, right? So they might overinvest and end up having extra capacity and lots of water that they don't have customers for, right?
Right.
And I would just say one last thing for this specific piece is what worries me all the time is, if you think about, let's talk about energy transition and water transition as a parallel. When you look at energy transition, who has solar panels on their roofs? Wealthier area, people who can afford it, people who can have the capacity, people who own their homes and all that, right? So it leaves people who do not have that capacity behind to pay for a centralized aging infrastructure, right?
Mm-hmm.
So if we are doing something like this, we have to be very much mindful of this because, for example, if utilities accounting for population growth, demand grows, and people start transitioning regardless to these kind of models, 20 years from now, they will have a lot of extra water, which then only people who could not afford to pay for these decentralized systems, becoming these prosumers, as I call them, producer and a consumer of the water. They don't become part of that category, right?
Mm-hmm.
And so you're actually impacting low-income people, disadvantaged communities as part of this process.
Yeah, that is very interesting. I really like your analogy between energy transition and these water changes to decentralization, and I love the concept of consumer, producer, prosumer. Because I mean, sometimes you would ask somebody, "Well, where did you get that?" Or some type of food or whatever, and they say at the store.
Exactly. Where
And
does
that's
your
kind
water
of like
come from? Out of my town.
and that's kind of the level of knowledge that a lot of people have about water. It just comes out of the tap. But then they not only maybe they may not understand where it's coming from, but also where it's going and wastewater and everything. And so if they become more engaged then because they're taking ownership and developing their own systems and getting off the grid a little bit, then
Right.
I think we'll be dealing with a much more knowledgeable group of people. And I think some of the things that you were explaining earlier was that sometimes these ideas can permeate a neighborhood. And, if your neighbor is doing it, you can ask them who did it and how did you do it and everything. That's a lot more easier to take up than, if somebody is saying from the federal agencies or whatever, do such and such. So these are really social experiments.
Very much social experiments. Absolutely. And we saw that in our studies. For example, I did mention that at the beginning, but a lot of these incentives that's provided by utilities, while they're important, they're not the ones who end up creating these social norms. Your neighbor doing it is creating social norm because people don't have the time or the energy to go figure out you need one interested party to do all the research and get all the information together and show up at your neighbor's house. And then you're like, oh, I want to do my lawns. So now I have somebody who can do it, right? Replace my backyard. Or they're, installing solar panels so they can do that. So those social norms very much matters. And we actually did a study that showed that very clearly how people respond. Gradually, these bubbles grow. As one person does it, they start becoming the centroid for a big change.
Well, I mean, I think nothing showed that to me more than the supermarkets that you could send in your list and then pick up your items, I think, oh, how crazy, And then we have the pandemic, and then a lot of people are using it. So you can never tell.
You can never tell. You just need one trigger. I mean, even for the energy sector, there were a few triggers that made them transition. It wasn't just they woke up one morning and said, let's do solar panels on people's roofs. It was a process through which, we had the energy crisis in the late 90s and the Enron crisis. And then all of that sort of added up to these policy change that we did that ended up kind of creating a new market and new changes and provided incentives to create, to sort of enable change.
Right. And of course, it didn't hurt that the price of solar panels with increasing demand then dropped off a cliff,
Yes.
So made
it
feasible.
Absolutely.
So expanding beyond irrigating lawns and stuff is basically irrigation for food production, which is a huge issue in California and many regions globally. So Southern California, you've done quite a bit of work there. They received water from the Colorado, and everybody is talking about the Colorado these days. But in the early 2000s, California was required to reduce their water usage from the Colorado because Arizona was taking their allocation then, and so California had been taking more than their allocation. So it seems like, San Diego, made some deals with the irrigators and they had water, purchased water rights from the irrigators long-term, 60 or 70 years, and made the irrigation more efficient. And so there was a trade there. And I think you mentioned utilities have relationships with irrigators during a drought to fallow land or things like that. Maybe you can describe those things a little bit, Newsha.
Yeah, absolutely. So this deals that are not new. A lot of these utilities in California has been having these dry year contracts with irrigation districts, which basically says, as you said, during this dry period, this much land will be fallowed, and that water temporarily, obviously, will be transferred to urban areas to survive the drought and then go back to normal. There's various reasons for it. One is like you can't permanently transfer your water rights because there is a very specific laws and regulations around that. So these temporary deals work very well. And, we used to have short droughts, as I mentioned earlier. I mean, if you look at California, I did tons of hydroeconomic modelings. In all of those, you would say every 10 years, we will have 3 years of drought. That's what it was. Sometimes you would go even longer without having the big drought period. But, to be honest with you, since 2000, we have been in more dry and drought years. We have than wet years. We have broken so many records, both on a wet side and a dry side. The heat is a huge problem, right? It's not just about droughts because you get less water or snow. It's also, we have higher temperatures that make the snow evaporate or disappear faster or melt faster. This is just basically wreaking havoc into our existing system that we had dependent on for a long time. So these deals, while they have worked for a long time, they're sort of having a lot of issues. Also, now with Colorado, we're having this, they have been in 20 years of drought. There is an issue around, so what do we do now? And the problem, I think, with these water rights is people have caught pieces of paper that says, you have access to this much water. But that much water, it was never put in a form of proportional to what? This much water compared to what exactly, right? they basically took a river and divided it up as if like my mom will make a pie and we divided it into pieces. It would always be the same mold, the same amount, the same everything. We just take our pieces. But the reality is, obviously, we have less water in the system. We have over allocated that water. And what we see in Colorado is not just a matter of hydrological drought that we are experiencing. It's also the poor resource management. We kind of like keep over allocating everything, hoping that next year would be different. Right? It's just like praying for rain for next year. And that system doesn't work. And we saw that in the past year. And, I've been a huge advocate of transitioning from this water right system that we have into a proportional water right, which is more like you have a percentage of the water in the river. Now, if this year the pie is smaller, if we get less water, then everybody gets a proportion of that water. But obviously the proportion of a small pie is much smaller than compared to a big pie. So then that way, and also you need to bring then the ecosystem and the tribes to the table as well to make sure they also get a portion of this. So it's kind of like it changes the dynamics very much. But the way we work right now is more like who came first, who came last, how much do I get? I'm an older kid, so I get this much bigger, and pie is always the same size. So, and I think the attitude is more like, we'll do this till it works. But at some point, this will break, right? So we have to kind of think about how do we adapt? How do we transition?
Right. Yeah. And the Imperial Irrigation District, that was sort of a unique situation, right? I think you were explaining.
Very unique. Yes. Like a handful of families.
Right. So it's much easier to make it happen.
Much easier. You have a handful of families that own those water rights. And they're very small and closed group. And so they can do a lot of things while other areas cannot. And they actually made that deal with San Diego, and that we are not going to go down the San Diego route. There are a lot of different things that San Diego has done that has caused them a lot of heartache over the years. But also, I'm not 100% sure how much longer we'll have enough water in that system to be going to Imperial to ending up in San Diego for people to water their lawns. Again, like, I want to go back to connect it to the actual reality of it's not like you're providing essential services to people. It's not like people don't have access to water for survival. We're talking about a lot of waste and fluff in the system that needs to be taught and repurposed.
Right. And I think that's a good point. But having that buffer means that we have an opportunity to change. If we were already lean and mean, there would be much less opportunity. So we know that we have a lot of buffer. So that's good. But then we need to make those changes. So, and I think we will be forced to.
We will be forced to, absolutely. I think either we'll do it ourselves logically at the table now and anticipate what's coming next and respond to it logically, or our hand will be forced to change.
Right.
So it's a choice.
Yeah. I really enjoyed the study you did on water and food production in Mexico. With the desalinated brackish water and the linkages between energy and food and trade and all of those things. Maybe you can describe that a little bit, Newsha.
Sure. We went down to Mexico actually for a trip. That's how this whole study started, to focus on water energy nexus issues. And as I was sitting in a conference room, one individual researcher came in and started talking about all these different fruits that are growing in Mexico using desalinated water, because we were talking about desalination and water energy nexus in that context. So here I am thinking, what? We're using desalinated water to grow like strawberries and blueberries? And that actually started this whole very detailed investigation and studying of this process to better understand what is going on, who does the desal, how do these farms function. So it's very interesting because, we often, we have done this in many contexts. This is not just the only thing we do. But we have a few companies that have gone down to Mexico, bought land, or worked with local farmers. I mean, different ways. But at the end of the day, these lands are owned by these companies. And then desalination is cheap there for various reasons. First of all, when they started, the water wasn't that salty. They kept extracting groundwater and watering these fruits and vegetables. And as you know better than anybody, as you start extracting groundwater, especially in the coastal groundwater basins, that vacuum starts filling up with seawater, which we call it seawater intrusion. So over time, this groundwater has become saltier and saltier, and fresh fruits do not like salty water. So what do? You don't stop operations because the land is cheap and the labor is cheap. So they started desalinating water. Now, how does this work? Because they have a tariff that allows them to have access to cheap energy. That means that they have reduced the cost of energy for them to operate the small desalination plants. And then also, they have no specific regulations around brine discharge, right? So no one knows what happens to that brine. So you have all these I call them policy vacuums. We have very strict rules around how we do desaling in California, or how do we use how do you install desalination facilities? And energy is very expensive here, right? So then we have gone somewhere else with limited regulations and cheap and policy incentives. I guess that's to enable this, what we want, because we all want cheap strawberries, because why would one want to pay more for strawberries if they can be $6 a box versus $10? That's great. Mm-hmm. It is fascinating for various reasons. One, we are having a huge environmental impact there. We are having a huge carbon footprint there. Lots of, we use that energy. That energy is not all like clean energy, so the carbon footprint is real. And then on top of that, there's a huge social issue, because people who used to come to this region used to always was an agricultural hub, but it used to be a sort of seasonal hub. So people would come, seasonal workers would come, work the land for like 6 months, 4 months, 5 months, they move and come back again. Now they're operating 24/7. Mm-hmm. So people have moved to this region, and without having any social infrastructure. They don't have access to water. The water, as I said, is very salty now because it has seawater intrusion, but there's no desalination for people who are working in these farms. Mm-hmm. So there are trucks that come in, and people are paying for water out of these trucks, a lot of money. There have been discussions around putting a desalination plant for people. But remember that tariff that I said, it's only for businesses. So if you build a desalination plant for people, that doesn't apply to that. Mm-hmm. So you're creating this sort of trilemma of having water, carbon, and social impact at the same time, just because people can. It's a policy vacuum.
And they're exporting the food then, right?
All of it comes to the U.S. Mm-hmm. All of that ends up in the U.S. Mm-hmm. So we are basically creating it's a virtual water, right? Mm-hmm. But it's not just the virtual water. We are also, yes, you can say, they're creating jobs. Sure. But still, you're also that tariff that's being used to bring down the cost of energy. It's
subsidizing the U.S.
It's subsidizing the U.S., which is
crazy.
Crazy. Absolutely.
Yeah.
Yes. Yeah. But one other thing I would say about that story, and I think we sort of touched on this a few times, is we are all very obsessed with, especially academia, with these like large scale projects that talks about global impacts, right? And a lot of these things that we just talked about, from water use to water, food, energy nexus to, I don't know, Colorado water issues. If you do global studies, it masks a lot of these things. They make them look insignificant. But so that I call it the problem with scale versus scope. If you're focusing on scale, you miss nuances, you miss scope, you miss local impacts. And if you really want to be intentional around having less unintended consequences socially and environmentally, we do need to zoom in.
Right. Well, I guess that I really enjoyed reading that paper. I thought it was so interesting. And I think, we see some of this in developing countries and subsidies. India, subsidizing electricity. And then if they export the food and stuff like that. And
Africa.
Yes, right. Yeah. So, last question I would like to discuss with you. You're serving on the Public Utility Commission in San Francisco, and in much of your discussion, you link water and energy, and just the last conversation was about food also. How, I think it seems to highlight the importance of considering water in a broader context. We can't just look for solutions for water on their own. We need to consider what are the energy implications, what are the cost implications. And I really like that you work with social scientists and economists. It's so much fun, isn't it, to get their perspective? And but we need that comprehensive approach to develop appropriate solutions to any of these problems these days, I think.
Absolutely. I think we have we always again, like not going back to academia, but the reality is a lot of people doing a lot of research to focus on one thing, but we need multitude of talents. We need people who can do deep research on a topic. We also need people who are on top of the tea. The way I think about it is that the bottom of the tea and top of the tea. We need people who can do top of the tea, be able to bring a lot of different perspectives together, connect them and tie them together, and be able to provide a system level perspective. And that is often not as much valued or encouraged. And that's why, sort of, for example, if you sort of want to get out and serve on these political positions, it takes time, it takes energy, it takes commitment, but it teaches a lot of different things. I personally do it because I'm learning new things every day. And I have so many aha moments when I'm sitting in these boardrooms or having these discussions, especially when you're having people with so many different backgrounds. All of a sudden you realize, oh, I totally missed that perspective or that point of view. And I think we need to encourage a lot more than this. We need to have a next generation of interdisciplinary thinkers who can actually sort of sew all these peoples together, create this thread between all these different topics, and be able to connect them all. That I think that's very important. And I do it because obviously it's a great service. I love the city and that I live in, and I want to be helpful and useful. But it also teaches me things every day.
I agree. We certainly need people to do deep dives into different things and stuff like that. But, we see cities developing plans now, future plans and everything. And it's all portfolios of all these different options. And we need to be able to look at the trade-offs between different solutions, and try to optimize and to make sure that the vulnerable communities are not getting nuked, with different solutions. So it's very challenging.
Very challenging. And I think it goes back to the comment I made with sort of transition to these distributed solutions. With them, we totally need to rethink how we do things, right? And to your point, water needs to be central to so many of these discussions, but often it's not. So we need to kind of and some of these decisions are made by experts, but some are made by people who are very much focused on one topic or one that have been trained to think about these singular focus issues. So yes, I mean, I would like to see water more central to a lot of the planning that we do in our cities and communities. And also, I think these trade-offs needs to be measured. But again, going back to scope versus scale, if you're not thinking about these, like you see the trade-offs at the boundary layers, right? Where systems touch. And if you're not focusing on those boundary layers and zooming in, it's very hard to see them sometimes.
Well, thank you so much for talking with me today. I really appreciate it, Newsha. So Newsha Ajami is the Chief Development Officer for Research in Earth and Environmental Areas at Lawrence Berkeley National Lab. Thanks a lot.
Thanks for having me. Really appreciate it.